Hey, we're back. So today's math lesson, continuing with learning factors, are the nines. Oh, nobody likes to count by nines. Nines are hard, but Bob's got a couple of cool tricks to help you figure it out. And when Bob's done, we're going to go to the board, and I've got a really cool trick. How using your fingers, some tools for math, can help you solve the nine facts pretty easy. So, Bob, take it away.
How can patterns be used to find nines facts? Think about this question during the lesson. The owner of a flower shop puts 9 roses in each package. How many roses are in 8 packages? To solve the problem, do you need to know how many roses are in each package? Yes, because you need to find how many roses are in 8 packages. Use patterns to find 8 times 9. What property says that changing the order of the factors does not change the product? The commutative property of multiplication says that changing the order of factors does not change the product. One way to find 8 times 9 is to use patterns to find the product. What do you notice about the ones place in each product? The ones digit in the product decreases by 1 each time. What do you notice about the tens place in each product? The tens digit in the product increases by 1 each time. How can you use the product of 5 times 9 to find 6 times 9? The ones digit will be 1 less than 5, so the ones digit will be 4. The tens digit will be 1 more than 4, so the tens digit will be 5. So 6 times 9 equals 54. Continue the pattern and find 8 times 9. The ones digit decreases by 1 each time. So the next ones digit is 2. The tens digit increases by 1 each time. So the next tens digit is 7. Now let's work on another way to solve 8 times 9. Begin by looking at the factor being multiplied by 9. The tens digit is 1 less than the factor being multiplied by 9. The digits of the product have a sum of 9. Think. 7 plus what number equals 9? 7 plus 2 equals 9. So 8 times 9 equals 72. How do you know that the ones digit in the product must be 2? The sum of the 2 digits of the product must be 9. Because the tens digit is 7, the ones digit must be 2. There are 72 roses in 8 packages.
Okay, so turn in your book to page 68. And I don't know about you, but I think Bob completely confused everybody. It's a little complicated, but it also follows a pattern that can help you solve the nines. And then, like I said, I'll show you a trick here in a minute on how to solve the nines too. So what Bob was saying, if you look at the chart here, you'll notice that the ones place goes down by 1 each time. Let me try to lay that a little flatter so you can see it better. So the ones place starts at 0 and goes 9, 8, 7, 6, 5, 4, 3. And then here we would have a 2. and here we would have a 1. Now the tens place, you'll notice, goes up by 1. 1, 2, 3, 4, 5, 6. This would be a 7, and this would be an 8. Okay, another thing about the nines, the multiples of 9, is that the two digits add together to equal 9. So 0, well, that doesn't count. But here the first digit we would say is a 0, and 0 plus 9 equals 9. 1 plus 8 equals 9. 2 plus 7 equals 9. 3 plus 6 equals 9. 4 and 5 is 9. 5 and 4 is 9. 6 and 3 is 9. 7 and 2 is 9. 8 and 1 is 9. So when you add the two digits together, they also equal 9. That will help you to know if a number is a multiple of 9. And if you don't have this chart handy, well, that's a little bit trickier. But if you can remember one certain fact, you can kind of go from that to get more. So let's look at, another way, sorry. What they're talking about here, another way actually is what it says. If we're multiplying, and I'm going to write it bigger up here, 5 times 9. Okay, the tens place is going to be 1 less than whatever you're multiplying with 9, the factor that isn't the 9. So 1 less than 5 is a 4. And then you know that the other digit has to help it add up to 9. So 4 plus what equals 9? Well, you can do some finger math, or maybe you remember, but 4 plus 5 equals 9, so that has to be 45. If we wanted to do 7 times 9. Okay? The tens place has to be 1 less than this factor, so it's going to be a 6. And 6 plus what equals 9? Well, again, finger math, or remember, it's 3. 6 and 3 is 9, so the answer would be 63. So that's just a couple little ways to maybe help you through this. Let's look down here at the bottom to convince me. Use the patterns above to find 9 times 9. Well, we already did that. It was 81. Explain how we got that product. Well, however you did it. Maybe you knew that the 9, the tens place would be 1 less than the 9, and then the two digits had to equal 9 when you add them together. However you figured it out, you can write that here. Now let's look up here at the do you understand? Do you understand? Paul thinks 3 times 9 is 24. Use a nines pattern to show that Paul is wrong. All right. Well, first of all, we can tell he's wrong because remember, the two digits in the answer, which is a product is an answer to a multiplication problem. The two digits have to equal 9. 2 plus 4 does not equal 9. That equals 6. So right there we know that. We can say that 2 plus 4 equals 6. So he's wrong. Another pattern we can say as well, the tens place will be 1 less than the 3. And that it has to be, the other digit has to help this add up to 9. So it has to be 7. So 3 times 9 equals 27. Paul is wrong. Number 2, look at the table of nines facts and describe a number pattern in the multiples of 9. What does that mean? Well, a number pattern, we could say what they told us in the video also. The ones place decreases by 1. And the tens place increases by 1. Whoop. As you go down the chart, as you increase what you're multiplying by. All right, over here, 3 through 10, find the product. Again, a product is an answer to a multiplication problem. You've got a chart here, and just use that chart. 9 times 2, 18. 5 times 9, 45. 7 times 9. 4 times 9 is 36. 2 times 9 is 18. 5 times 9 is 54. 3 times 9 is 27, and 8 times 9 is 72.
when you do your work, you've got a chart there. It's kind of a cheaty chart. That's okay. It's a tool, and we're talking about using tools. Speaking of using tools, I'm going to show you a cool trick that you can do with your fingers. And I'm going to turn this off real quick to help you get the nines. So again, your fingers are a good tool for math. You can count on your fingers. You can use your fingers to count by multiples of 2. They help. So here's a cool nines trick. Let's say that we're going to do, I'll erase this. Let's do 3 times 9. So here's the cool trick, and I gotta turn my back to you because you gotta hold your hands up this way, okay? So you're gonna have your hands out on the table or in front of you, and you're gonna think of your fingers as finger number 1, 2, 3, 4, 5, finger number 6, 7, 8, 9, 10, okay? They have to go that way. Starting on your left pinky, over to your right pinky. So 3 times 9, you're gonna take finger number 3, 1, 2, 3, and you're gonna put him down. Now what you have left here, this will be your tens place, so I have 2 in my tens, that's 20. And then this is how many ones are left over. 1, 2, 3, 4, 5, 6, 7. So the answer would be 27. Just like that. Let's try another one. Let's do 4 times 9. No, that's pretty close to what we had. Let's do 6 times 9. Lay your hands out. Remember, it's finger 1, 2, 3, 4, 5, 6. So we're going to hide our thumb. So the answer is, these are your tens place, which you got on this side. So that's 50. And then you've got ones, 4. The answer is 54. Let's do one more. Let's do 8 times 9. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to hide that finger. So my tens place is what's on the left. So that's 7. And then I got 2 in the ones place. So 72. Magic. That's a neat little trick. Just another way to help you learn the nines. Use every tool you have to help you with these things. And your fingers can be a good tool too.